NASA and the USGS are preparing a new satellite, the Landsat Data Continuity Mission, called LDCM. Landsat satellites have been orbiting Earth since 1972, taking scientific measurements of land cover and land use. LDCM is the 8th Landsat satellite and will continue the world's longest global data record of changes of the Earth's land surfaces. LDCM data will also play a critical role in monitoring, understanding, and managing the world's forests, agriculture, and water.
What this data is useful for is to provide information to the scientists, particularly out in the western states where water is a very big deal. This remote data allows them to determine where areas are being irrigated and how much and how often.
TIRS is the thermal infrared sensor that is being built and tested here at Goddard Space Flight Center for flight on the next Landsat mission. It's designed to measure the amount of thermal radiation emitted by the surface of the Earth as a function of the Earth's temperature. All objects that are warmer than zero, absolute zero, emit radiation. The hotter an object is, the shorter in wavelength is the peak radiation.
For example, the sun is very hot, about 10,000 degrees, and its radiation peaks at about 0.5 micrometers. That's exactly in the region our eyes can see. Earth is much cooler, so its radiation has a much longer wavelength, about 10 micrometers. And that's in the far infrared region, well beyond what we can see.
So basically what the thermal infrared sensor allows us to do is to determine the temperature of the surface of the Earth at different locations around the globe.
From these surface temperatures, scientists can determine how much moisture is present in both soil and vegetation. Water from irrigation and rain soaks into the ground and nourishes plants. When water evaporates from the soil, it cools the air. At the same time, water also transpires from the leaves of the plants, and that also cools the air.
You put those two words together and you have the science term evapotranspiration, and that's precisely what TIRS is measuring, these hot and cold signatures that give us information on evapotranspiration, where the water is transpiring through the plants and evaporating into the atmosphere. The instrument is going to pick that up as a cool signature, and areas that are not being irrigated well will come across as a warm area to the instrument.
To measure these warm areas and cool signatures, the TIRS instrument uses a technology array developed primarily at NASA's Goddard Space Flight Center. Called quantum well infrared photodetectors, these QIPs are more sensitive and precise than the thermal detectors used on previous Landsat satellites. But to operate correctly, they need to be kept very cold.
They have to be cooled to less than 43 degrees Kelvin. And so that's only 43 degrees above absolute zero, which is the coldest you can get. Very, very cold.
The interesting thing about TIRS is we have different thermal zones. You know, like our detectors are around 43 Kelvin. Then you have our telescope at 180 Kelvin. And then you go to the warmer end of our instrument, which is the structure and some other components that are around, 0C or 273 Kelvin.
Keeping these different TIRS components at these different temperatures is challenging because as the satellite orbits the Earth, every 90 minutes it's either being blasted by the heat of the sun or being frozen by the cold of space.
So you're exposing the instrument to these two harsh conditions, and you're cycling it from one to the other. One of the things that we do on our sensor unit is we have multi-layer insulation blankets. These work really well in space because there's no environment, there's no air. The blankets protect us from these extreme conditions. The other thing we use is we have an earth shield.
It is basically a 5-foot door. It's about 5 feet long, and it shields much of the instrument from the Earth, the parts of the Earth that we're not imaging. That's a tremendous help in trying to make sure that we only detect the signals that we're interested in, the heat sources that we're interested in.
And detecting those heat sources accurately helps to monitor water use in irrigated fields.
Observations that are collected with the Landsat sensors are much more than pretty pictures. They are accurate, well-calibrated, precise scientific measurements. One of the things we're learning with thermal data, and we'll continue to learn more about with TIRS, is just how much water is being used for food production, and how much more might be needed in the future to increase food production to keep up with a growing population.
TIRS thermal data as part of the LDCM mission will add to the more than 3 million images of the Earth that make up the Landsat Data Archive.